Welcome back to Medlysis, where we explore healthcare systems in depth. I'm Kiwi Kohli.
And I'm Mansi Bhatia. Today we're excited to welcome our very own TA here at the University of Toronto, Melody, a postdoctoral researcher studying fatty acid synthase at the PMCRT in Toronto. She completed her BSc in biology at York University and earned a PhD at the University of Toronto under the guidance of Dr. Simon Sharp, focusing on serum amyloid A.
It's great to have you here, Melody. Your background sounds fascinating. To start off, what potential therapeutic applications could arise from a better understanding of fatty acid synthase's structure and function in cancer treatment?
Thank you so much for the amazing introduction. So fatty acid synthase is a very large enzyme that is present in all mammals and even bacteria. And the overexpression of fatty acid synthase is one of the hallmarks of cancer because, as you can imagine, cancer involves the growth of lots of cells that give rise to a tumor, and that requires a lot of lipids as well. So that's why the fatty acid synthase gets overexpressed in those cells. And we want to find high resolution structures of this enzyme in different catalytic stages, so that can help with the design of anti-cancer drugs. And also, a lot of cancer patients, they also are infected with secondary infections because the chemotherapy treatments makes their immune system very weak. So they can get, for example, additional fungal infections. And the fatty acid synthase can also be targeted in those pathogens as well, which is what we're trying to do, is to study using cryo-EM or cryo-electron microscopy, these different structures of both mammalian and fungal fatty acid synthase.
That's a crucial area of research. How can your research findings be translated into clinical practices for managing inflammatory diseases?
So inflammatory diseases could have arthritis, obesity, diabetes. All of these could potentially give rise to chronic inflammation. And chronic inflammation will practically disrupt the biochemistry of the body over time. It changes everything, all the transport mechanisms and metabolism. And the area that I focused on in my PhD was lipid transport, and a protein that is particularly overexpressed during chronic inflammation. And I found that its structure is different depending on the lipid that it transports. And this could potentially also be used, like the structures can be used to find therapeutics to prevent the chronic inflammation and also secondary amyloid formation that may be happening long term.
That's incredible. How do you see your findings translating into clinical practices, particularly for managing inflammatory diseases?
So in the lab, we mostly do basic science, and we find, and my area of research particularly is structural biology. So I have expertise in nuclear magnetic resonance or NMR. Now I'm trying to learn more about electron microscopy and cryo-EM and small angle X-ray scattering. And all of these different structural techniques can be used to find a high resolution structure. And so for me, I'm not going to be actually designing the drugs, but the work that we publish in our labs could potentially be used to find drugs that could target the specific catalytic sites. So that is something that will be done by other groups.
Oh, that's pretty interesting, I must say. Understanding the molecular pathways you're working on clearly has important implications for drug development. But what impact do you see your work having on public health at large? And could you please explain how your research might translate into broader health outcomes that may relate to public?
Okay. Well, to put it simply, in all of my years of doing research, one common thing that I came to realize is how complicated just biochemistry and the body is. And even now, we still don't know so much about it. And it's kind of impossible to know everything, which is why the best recommendation I would have is to just first try to be healthy and have a healthy lifestyle before even waiting for any drugs to be found, because even drug system, it still isn't perfect. So it's always better to avoid going to the doctor, I would say, or avoid getting treatments. A lot of drugs, they have side effects, and the molecular interactions are very, very complicated and unpredictable sometimes. So that's the way I'm trying to live.
Looking ahead, how might future studies on fatty acid synthase impact our approach to dietary recommendations in metabolic health?
So, I think initially, just being, following a healthy diet is very important. But once the body goes into an unhealthy state, its whole metabolism and transport of lipids like changes. So it doesn't matter as much once you fall into that like disease state. Um, it's kind of hard to get out of it. But before that, just following the general dietary amounts and recommendations, I would say always exercising. The basic things we always hear, those are the things that work. But yeah,
Before we wrap up, what advice would you give to aspiring scientists who want to pursue a career in research?
I would say that go for it. Even if you, I think research just opens up your eyes to how your body works at a molecular level. And even if you don't become a professor in your lifetime, it can still help like the way you live and appreciate life every day. So I recommend it to everyone. I recommend science and pursuing research for different reasons. Even if you don't reach the high academic levels, it's still worth it.
Thank you so much for those insights. We've really enjoyed hearing about your work and its implications.
Yes, thank you so much for joining us today. We look forward to seeing how your research progresses.
So thank you so much for having me. Have a great day.
Thank you.
You too. That's it for today's episode. If you enjoyed our discussion, don't forget to subscribe and leave us a like and comment what you'd like to see more of in the future.
And join us for more fascinating insights into the world of science. Until then, stay curious.